I am Carl Moberg. I am the CTO at Avassa, and this is Fredrik Jansson, who is a solution architect, and he's going to do the demo for us. This presentation is called Security Horses for Edge Courses, Safeguarding On-Site Edge Applications and Data. And I will say that we are Avassa, of course. We provide an application management and operations platform for the on-site edge. This means that we help our customers manage the infrastructure and the applications outside of the cloud, which is usually how they define edge. They do that on distributed infrastructure and in an automated, secure, and scalable fashion. And by on-site edge, we mean locations where these enterprises put small amounts of compute, small number of computers, to support applications that they need running close to data sources and users or clients. And this is a common pattern across many industries. We work in retail, where they put a lot of computers in the stores, industrial manufacturing, where they put computers on the factory floor, and marine environments, for example, where they thoroughly digitalize their ships. So it's almost like they're becoming mini data centers. So let's take a look at the well-known 7 layers of security. I'm going to use this as a little bit of a vehicle to discuss the security posture. We'll look at the cloud, and then we'll make a little bit of a contrast with the edge, and then we'll show you the manifestation, if you like, of that in our system through a demo that Fredrik will do. So if we start by the cloud, so this is pretty well known, so I won't spend too much time on this. It's been around for a while, pretty well understood. So applying these 7 layers is pretty straightforward. I like to talk about this as attackable surfaces on the right side, right? So they're well known, and what that means is that there are also nice and well understood security measures in place to kind of combat this. What I want to point out here, and what we have in the illustration, is that there's usually a split in responsibilities between, in the public cloud case, the public service provider or the cloud service provider takes charge of or takes responsibility for the lower layers. The human layer, no one can do anything about, of course. And while in the private cloud case, the full stack is actually covered by the enterprise. So there's a little bit of a split of responsibilities here between the users. And of course, the lower layer has to do with things like physical perimeter security, mostly to do with infrastructure, and the top level is kind of, if you like, application teams and up. Now, if we do a little pivot and add the edge here, one of the things that is different and something we observe is, of course, that the 7 layers still apply. It's just that people tend to not think about it like this. I guess the second thing is that for many of our users, the on-prem security measures now solidly lands on them. So they don't rely on a service provider for that, but they actually have to care about the lower layers of security in their on-site environments, which can range from not super complicated, if you think about manufacturing plants, pretty well protected, to much more complicated if you're in a retail store, or for that matter, in a public environment for smart grids, for example, where the compute hosts may actually be at arm's length from the general public, where that becomes more interesting. And what also becomes very important, particularly for the top layer here, is that the impact of the fact that this is a distributed environment where you have this kind of instances of these attackable surfaces. For example, in our demo setup that we'll show you later here, is in 10,000 locations, right? So if you want to have some means of doing this, you have to think about a deeply automated set of tools for this, because if you run a single data center or you run your stuff in 2 private data centers, you can actually go to that data center and do whatever you need to do. If you run it in 10,000 locations, let's just say that it's going to be prohibitively expensive. So that's a pretty significant difference between the 2 sides here.
I can see how the lower part of this looks just radically different.
Yeah.
On so many dimensions. Just to start, the staff that you might have available. But why would the upper actually necessarily look any different? We're not really talking, I don't think we're really talking about latency dependent operations.
That's right.
So why should it look any different?
I'll give you one example. Most applications today and I'm going to stick to container applications, require some sort of sensitive data to function. Might be a certificate, might be application credentials. Now, in the cloud world, you then have those instances of those residing in 2 locations. Suddenly, if you're a big retailer, you may have really sensitive data in 10,000 locations. Now, I won't forego the demo, but someone may gain access to that. Then you can't really do that in one location. You can't remediate that in one location. Suddenly, you have an attackable surface that consists of 10,000 instances of application and data security.
So it's like scale out of attack vectors.
Yes. Lateral access, for example, lateral attacks.
It's really just multiplying the attack surface that you have across a huge set of potentially not interconnected or randomly not interconnected or connection sites and locations, right?
And I'm struggling so hard to not talk about the demo content now. So it's a great setup question. And we'll
get... ask it again later? I guess I'm thinking from the management standpoint. I still feel like the abstraction required to take you to management, the console could look exactly the same.
It could, if you bought something from a vendor like us. If you look at...
Wow.
If you look,
really?
How about that pivot? Seriously, if you look at the way, for example, as you can imagine, all jokes aside, our most common competition is in-house, right? So people build this on their own.
Yeah, I don't think I stated that well.
Okay,
I understand what you just described. What I summarized, and Jack summarized, is sort of scale out. Like you may have what was once 2 can now easily become 2,000.
Yeah.
That could take place in the cloud as well. You need to build for that as well. The example that you gave sort of set up the answer for you, which was that in the cloud you only have 2, but you may have 2,000 in the cloud. You may have 4.
Yeah.
You need to. I feel like you need to address both of them in the same way. So I'm still not seeing the difference.
So okay. Let's say some of this I hope will be answered by the demo. But maybe another angle is to say, if you look at the part of the operation stack that we've seen that kind of takes on those attackable surfaces for the cloud, they simply won't work for the edge, simply because of the scale. And it comes both with some economical things. So if you think about CyberArk or Vault, for example, to protect your data, neither of those will even be close to actually working, even in hundreds of locations. They simply weren't built for that. So there's no way to address, for example, 1,000 instances of Vault at the same time because you want to do something, right? That's simply not how it works. And going back to what I said before, you need the instance of that in each site. You can't have it central because then your outage exposure is crazy. So that actually, well, it is a multiplier. I'd like to think about it as something even more complex, but at the heart of it, it is a multiplier of that. And that drives pretty crazy operational challenges, particularly if you try to take and use something that was literally built for and born in the cloud and apply to.
Conceptually, it's not.
You're
there
right.
may be similarities,
right?
But in practice, no one has built for this yet.
Yes.
Okay.
Yeah, except for.
Well, maybe there's a vendor that has. We'll find out.
We shall see. All right. So let's talk about an example here. So it might be something really simple, like a store associate. This is always in retail a conversation. Forgetting to lock the back door when they're leaving for a long and dark and lonely night. Because there's always that guy, right? that forgets to lock the back door. And what happens then, actually, what does happen is physical theft becomes an issue. And again, not only in retail, but also in smart cities and many other occasions, this is actually a tangible and well-known threat. So if we look at what just happened, right? A host has been stolen. Fredrik, this is going to be a problem. I think we need to sound the alarm, right?
Yeah,
We've
absolutely.
been informed. We can actually see that the host is gone. Obvious breach of the security posture at the edge, and someone seems to have used the human layer, which is us, to breach the perimeter layer. And the good thing is, of course, that we do have appropriate security measures in place to address this unfortunate situation. So in this case, two things, and this is, again, it's a big topic. I'm going to talk about the two things that comes into play immediately when this kind of event takes place. Central to this setup, right? Central to any kind of edge setup is to be able to do two things. First of all, we need to protect the data belonging to the applications, belonging to the tenants that are the users of the system, right? So protecting whatever is running on this platform, that's one thing. Protecting the integrity of the actual infrastructure itself. We talked about lateral attacks, using whatever you learn from one place to attack others, is another almost orthogonal task. Both of them become very interesting when you have sites in the hundreds or thousands or tens of thousands. The way we go about to do this is that we use two means of applying cryptography. We use host certificates to protect the communication between the edge and the control tower. Actually, we use it for more than that. We use it to protect all layers of the infrastructure. It's a system level, if you like, certificate per host. And the second thing is that for each tenant, for each user that deploy applications, we generate keys to protect their data and actually protect the data passed between the applications in our version of a service mesh, which is a VXLAN and WireGuard combination. So each tenant has keys specific to them, so we can have deep isolation between tenants. We can protect them from looking at each other's data.
Is there any capability to use non-self-generated certificates for it?
Wow, good question.
We allow you to bring a CA that we can draw certificates from.
Okay.
I'm learning.
But since we want to be able to rotate certificates with a certain cadence and so forth,
Yeah.
we want the system to automate that. But you can definitely bring your own CA to use as a root certificate for the system.
Yeah. There's going to be a lot of there's quite a few use cases where doing self-signed certificates are just not allowed, or things like Acme or whatever.
Honestly, we're looking forward to that because, again, honestly, some of these things come a little later in the conversation with some of our users. We know it's going to be very important, so we're kind of looking forward to that conversation.
Gotcha.
So what data protection capabilities do you have built into your solution? Or do you rely upon the customer to provide their own encryption,
No.
whatever it is?
Do you want to?
Yeah, sure. So at a start, when our agent calls home, we can when it presents itself, we can use a TPM for that type of certificate. So it's rooted in the hardware. Then to Carl's point, we generate for each tenant that we have unique keys per site. So everything that goes on the wire or a data address for a particular tenant is encrypted, and that is all handled by us. Then we provide services for their applications if they want to use them, like encryption and decryption of data, generating encryption keys and decryption keys if they want that, rotations of those, generate certificates for their applications and rotation of those. So we do provide a bunch of services that our customers can use in their applications. So typically, they don't bring any type of encryption software themselves, apart from like consuming a certificate.
Do you integrate with any NDR solutions?
The fact that I actually don't know what that means is probably a no.
Network detection and response.
No.
Oh, no.
Or even asterisk DR. I mean, like EDR, XDR.
Actually, I think for me, the more important question is, you talked about a lot about keys, but you think that most customers aren't bringing their own solutions, but they are going to have centralized key management, right? So are you integrating with key management solutions?
Yes, we can absolutely integrate with, for example, with Kubernetes for key management, if you want that. And again, everything around that is API driven. So typically, it's if you have something esoteric you want to integrate with, we have APIs. If they have APIs, you're golden, I guess.
Okay.
And I guess now that I know what an NDR is, that would be the same play, is that we would assume that they could do some event-based, actions through our APIs. But we don't have an NDR style, the way I interpreted it now, feature set to react. Okay, so now that the host is stolen, of course, we have tools that is needed to be applied here, right?
Yes.
Two things, of course, the host certificates. What we're going to do now is that we're actually going to do something called quarantining. So now that we understand that this host has been stolen because security operations told us, we're going to quarantine that host. That does two things on a system level. It revokes the host certificate. So again, that's why we need the CA. And it's going to revoke the tenant keys, but only if the entire site is broken into. So if we were to quarantine the whole site because we thought they would have gained access to all of the hosts in the cluster, we would actually revoke the tenant keys for that site. Now that it's only one host, we know that they can't actually use that material to do anything because they will never be able to reconnect.
I'm getting confused between host and host and host. So
Okay.
Physical device stolen, that physical device has multiple container hosts or VMs or whatever running on it, right? So at what
I love terms. When I say host,
Okay.
I mean what used to be here.
The box.
That's right.
Yeah,
the
the
box.
box. Machine.
Sorry, yeah,
Okay.
the machine.
The machine.
Right. The physical host.
Okay.
Yeah.
So if that physical box is gone,
Yeah.
you're revoking, you put it in quarantine, you revoke the host certificate, and when do you revoke the tenant certificates? That's what I'm confused about.
So what complicates things are that there are actually 3 hosts here, and we want to continue operation on the other 2 hosts. So we don't want to shut down the entire site, the entire cluster. So what actually happens is when we unplug the power from that host, the encryption keys that it needs to manage the tenants and secrets and all that are actually lost. They're in memory. So should we boot that up, maybe as part of the demo later on? There is nothing on that machine that allows us to decrypt anything that is on the disk and bring back applications and secrets or anything like that. And it also needs, since it's part of a cluster, to talk to the other 2 machines to actually come up in a reasonable way. And that is also a security feature. But what you can do is, since I'm going to forego a demo a bit here to explain this, I guess, since we're going to bring back the machine and bring it on the same network, it will actually have network access to those machines. We will quarantine it, and that will tell the other machines to not accept this guy, even if it's on the same network. So if someone steals that host and brings it home to another network, there is no way it can get started and get those decryption keys.
So let me repeat that back, make sure I understand.
Yes, please.
On the host, the box that was just stolen by our hacker in the hoodie, so to speak, right? The host key, the host certificates are in memory, not in the TPM. So when you power off the box, those are gone forever. Is that what you said?
Correct.
Okay.
The only way to regain them is to get back in contact with the control tower.
Okay, so the control tower shoves in the certs each time. Now, what about the tenants that are running on that or the other 2 hosts? Where are those keys in the TPM of the box, or are they in?
So the keys are actually in our vault that we call Strongbox.
Okay.
That can be TPM based
Yes,
or
Can be
TPM backed.
Right. So the only thing I'm trying to figure out, and I'm sorry for diving too deep in
No.
this, is why you say you wouldn't revoke the tenant keys as soon as the host is compromised. Why wouldn't you revoke everything on it and just say, we know it's compromised in some way or another, let's just eject it and say, in order for it to, we have to start all over again. Once somebody else has their hands on the box, you can't guarantee anything. So why wouldn't you just say, you're done?
At least you would regenerate the keys.
Or
so that
regenerate
the old
the
key
keys.
couldn't be used.
That's
the
where
key
I'm
thing.
confused, is why make that distinction?
Wonderful thing.
Yeah, good question. I don't think I have the answer.
Okay, so
Yeah.
maybe we'll talk afterwards a little bit about
You
that.
could make that a default. I mean, you could, as an operations person, you could quarantine the whole site. That could be your intuition.
Right.
And then that would happen.
Yes.
But we don't do it by default, and that's your point.
Yeah, that's my
Well
point
taken.
is from a, when I wear my security hat,
Yeah.
it's once somebody else gets their hands on my stuff,
Yes.
I've lost physical, I've lost control over it. I can no longer guarantee anything about it.
Yeah.
Right. So anyway, I don't want to
Yeah,
prolong it.
no, it's a good point.
What a great way to switch to the demo. Awesome. We saw that guy forgot to lock the door. A booster took the computer. Infrastructure team got notified. We are going to quarantine the hosts, and we'll show you that the keying material related to the site then are revoked, and the host will not be able to reconnect, even though we actually get it back. Let's go to the demo.
Let's do it.
How do we get back the box?
We'll see. We'll start by doing this, I guess. So as you can see, our system now knows that this host is gone. It's not connected. The system doesn't know yet that it's been stolen. It just knows that it's not connected to the other machines for some reason. So what Carl said, since I know that it's been stolen, I'm gonna do this quarantine host thing, just as a security measure to not allow this host back in. And I guess we'll go into the role of the thief. So I'm gonna see if, given that I have some money here, if I can buy that host back from the street, maybe plug it back in, see what happens. $25, good enough. Cheap.
I will say that the on-logic boxes are slightly more expensive
Yeah,
than that.
that was an awesome price for this box. I'm gonna hook this back up so I can talk to it. And as you can imagine, this is fairly hard to prove something about. So about the only thing I can do on this guy is I'm actually gonna, if it wakes up here. Oh, there it is. So now I'm the thief, and by some way I get access to this. And again, it's kind of hard to prove anything around this. What I can say is there are no applications up and running. The only thing that is running, which you may or may not be able to see because of the font size, I guess, is our agent is up and running.
Okay, that's fine. That's fine. Okay, let's go back to the slide here. So, okay, very brief demo. We only looked at a small subset, had to do with perimeter breach. Of course, that surface. There's a whole slew of other things, as you can imagine. Traffic separation, quick and TLS call home, centralized secrets management we touched on. All these topics could probably be another kind of 20-minute section like this. So I'll just leave it by summarizing and saying that while, again, to your point, I mean, conceptually, the attackable surfaces are the same. That's why we have a standardized model for it. You should think a little differently about it because the edge is different enough. And, mostly driven by the fact that many of the key security features must be distributed to the on-site, right? You can't rely on centralized security measures. And of course, central management and automation is truly key, maybe more so here than in the kind of private and public cloud, to scalable security operations. You need to be able to react in a very distributed fashion to things or to events that happen maybe in a very local fashion. So of course, that's where automation or the requirements for automation kicks in. So that concludes the presentation, and thanks for listening. I'll be happy to answer any either new or follow-on questions.
So one of the questions that we always care about is data protection. So
Yep.
You've given it from the point of view of the confidentiality element of data protection, but I don't see an availability element. Is there any data, all of the nodes at the site get burnt down? What have we done about making sure that we can recreate our application state and get all of the little bits of persistent data that haven't yet been off-sited?
Yeah. So let's think about that in two layers. It's, again, a big can of worms. And I'll talk about what we can do first. So one of the large features of this system that we didn't touch on is our distributed secrets manager. So again, you can think about it as a very distributed vault or CyberArk. Customers usually use that for at least two things. One is credentials. The other one is actually configuration. We also see, maybe to an increasing amount, that our users leverage that as a distributed storage mechanism, which in a roadmap fashion isn't perfect. Because it kind of puts us closer to what you're talking about, which is kind of replicated distributed storage. We partner with some of those, but I will say that the uptake is not yet significant, because I will say that the topic that you are bringing up here is, again, for many of our users, kind of down the path. And there are two ways to take it on. The first one is to just ignore, which is pretty common. And maybe and try to be as stateless as possible and read things from the central environment, and never mind the outage scenarios, or at least synchronize now and then. And the other one is trying to solve it by themselves. And there's this whole, as you well know, the whole event-based architectures, and where you replicate enough of the data that you can recreate what was there before. So as far as we've seen this, it's the combination of using or maybe overusing our secrets manager, and then some homegrown things to alleviate the kind of the block storage like need.
If I just need to back up some JSON document, I'm going to misuse your secrets manager.
Yes,
as soon as I'm wanting to
very true, and
to store a bunch of images and so on.
But yeah, we've seen some base 64, being rammed into what's supposed to be a text-based storage mechanism.
And then this kind of related one is that you talk about multi-tenancy in your console, but one of the things we heard certainly in the first Edge field day was about multi-tenancy within the organization. You touched on having an external provider for maybe the advertising content that's being paid in store, and somebody else who's running the loyalty scheme.
Yes.
How are the provisions around there for multi-tenancy within your multi-tenancy?
So the multi-tenancy that we've built here, which is again one of the reasons why we had to go with a more lean container runtime than Kubernetes, needs to replicate all the features that we've talked about here on a tenant basis. So everything that we've talked about now, in terms of secrets management, data protection, the keying, host tenant material, are actually per tenant to the extent.
I want the multi-tenancy within that tenant.
Say that one.
Multi-tenancy within each of your customers. So there might be a provider who's providing a variety of providers.
Yes, exactly. So yeah, that's key to the system. I think I'm answering your question now. So is that there's usually, for customers that need that, there's one part of the organization that owns the infrastructure and then allows other parties to use subsets of the resources available at the edge. Did I